Assalamualaikum and hello everyone. Welcome to the video where we will be discussing past year question for the year of 2022 and 2023. In this video, we will discuss question 3 involving chapter 4 chemical bonding. Question A, selenium oxide is a colorless solid and one of the most available forms of selenium. Okay, 1 Roman, draw the Lewis structure of SeO2, selenium oxide. So, to draw the Lewis structure, first thing first, what you need to do is you have to find the proton number of our selenium and oxygen. If you refer back to the list of constants, you can see that the selenium, the number of proton for selenium is 34. So, once you have the number of proton, you can write down the electronic configuration, which is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p4. Okay, so that is for selenium. Okay, and then for oxygen, the proton number is 8, where it is 1s2, 2s2, 2p4. Okay, once you have written down the electronic configuration, next you have to determine the valence electron. So what is the valence electron? Valence is the outermost electron lah. Outermost means that our highest end. Okay, for the case of oxygen, our highest end is 2. Because this 2s2, 2p4. So oxygen, the valence electron for it is 6. Whereas for selenium, okay, the valence electron highest end is 4, 4p4. So if you refer back, we have our 4s2 as well. So we have to determine the valence, you have to add in the Sn on the p orbital. The same goes here. When oxygen we mentioned about, because highest end is 2, and then we have S and P. So when we add up these two values, we get the valence. The same goes for selenium. We add up electron on S and on P orbital. The highest end, n equal to 4. 3d10 is not the highest end lah. Okay, so selenium we also get the valence electron to be 6. Once you find the number of valence electron, then we can calculate the total valence electron. Okay, selenium we have only 1, but then it has 6 valence electron. Oxygen we have 2, so 6 times 2, 12 electron. So the total valence electron is 18. Okay, and then how to determine the center? When you draw the Lewis structure, you have to know the center lah. To know the center, it is easier for you to check based on the number of atom in the molecule, which one has the lowest number, has the least, which is our selenium. So it means that our selenium is our center, and then terminal will be our oxygen. Okay, next we have to connect this bond. Okay, remember for one each bond we have 2 electron. So here we have 2 bonds, so means that we have 4 electron total. So now we have 14 electron left. So what about the rest of the electron? Okay, first we have to make sure our terminal is octet. Okay, for example, if my selenium is bonded to hydrogen, hydrogen already got 2 electrons. So the maximum number of electron for hydrogen is 2. So we don't have to put any electron here lah. But this case, our oxygen, again, it was octet. Right now, the oxygen on the left-hand side already got 2 electron. So it needs 6 more to achieve octet. So the oxygen here got 2, 4, 6, 8. So 8 electron. Okay, and then we have to check another terminal on the right hand side. Again, our oxygen already got 2 electrons. So it needs 6 more electron. Now both of our terminal has 8 electron which achieve octet. Then we can minus the electron lah. Okay, the electron used just now is 12. So minus 12. So now we have 2 more electron. So where to put the 2 electron? Okay, since our terminal already achieved octet, so we're going to put these 2 on our central. Okay, so when we minus the electron, now we have no electron remain. Okay, and then this is not the Lewis structure. Check whether all the atom already achieve octet. So oxygen here got 8. The same goes oxygen on the right hand side. But our selenium only have 6 electron. Okay, so there are exception. Okay, incomplete octet only for berbal. Beryllium, boron, aluminium. But our selenium is not berbal lah. So the selenium must have 8. So how do we achieve octet? Okay, actually it will share the electron from the terminal. It's either on the right hand side or the left hand side. Both is fine lah. Okay, so what happened here is that I'm going to choose two electrons from one of my oxygen. So for example, I'm going to share for this part. Okay, so what happened now? Our structure will be like this, where our selenium will have a double bond with the right hand side. Again, why? Because the oxygen on the right hand side here share the electron with the selenium. So what happened when it shared the electron? So it has no lone pair right now lah. But then when we check here, we got 8. Selenium also got 8. Our oxygen, even though it's sharing the electron, you also got 1, 2, 3, 4, 5, 6, 7, 8. Okay, so all the atom now already achieve octet. So this is our Lewis structure. So that's the solution for question 1 Roman. So question 2, based on Vesper theory, predict the molecular geometry of SeO2, selenium oxide. So now it wants our shape of molecular geometry. Okay, so to draw the Lewis structure, you don't have to follow the shape. So for example, if you want to draw the selenium to be like this one, it's fine, because this is only our Lewis structure. But based on the molecular geometry or our shape, then we have to follow the shape. The drawing must follow the 3D shape lah. Okay, but then how do we determine the shape? So first, what I'm gonna write down is my class. So what does it mean by my class? Okay, usually for class we write down A, B, X, E, Y. B stands for bonding pair. How many atom does the central atom bond to? Okay, in this case, selenium bonding to 2 of our oxygen on the right hand side, on the left hand side. Even though here we have double bond, the bonding pair means that berapa bonding pair, how many friends lah, how many pair of atom it bonds to. Oxygen left, oxygen right, oxygen left. So I'm just gonna write down, it will be AB2. Okay, E stands for the number of lone pair. So again, A stands for our central atom lah. Check central atom. So here we can see it has one lone pair. One lone pair here. So AB2E, or if you want to write down AB2E1 point, it's fine. So what does it mean by AB2E1? You have to write down means that we have two bonding pair, as well as E1 stands for one lone pair. So that is the class for the selenium oxide. Okay, so that's the class. Okay, next step what we have to write down is the electron pair geometry. So you can also denote it as EPG. Okay, electron pair geometry, how to know? You have to add up your bonding pair plus your lone pair. So when we add up these two values, it is 3. So what is the electron pair geometry? When the electron pair geometry is 3, electron pair geometry, when the total is 3, it is trigonal planar. Okay, so we're going to write down our EPG is trigonal planar. Okay, but then the question asks for molecular geometry, or sometimes it is called as shape lah. Shape, molecular geometry is the same one. Okay, there are two cases. If there is no lone pair, our electron pair geometry will be equal to molecular geometry. But for this case, our selenium oxide has lone pair. So if we have lone pair, the electron pair will be different lah with our molecular geometry. Okay, so how to know the shape? Okay, here you know that originally, supposedly our selenium is trigonal planar. So what is the shape of trigonal planar? So again, trigonal planar, we have our central in the middle, and then we have 1, 2, 3. Okay, but then again, this is if we have 3 bonding pair. In this case, selenium has 2 bonding pair, 1 lone pair. So what I like to do is actually, I'm going to remove one of the bonding pair, okay, to replace it with the lone pair itself. So it'll be easier, cabut yang kepala dia ni lah. So this is our shape for selenium oxide, where we have 1 lone pair and 2 bonding pair. So how to determine the name? The name is based on the shape for your bonding pair lah. As you can see here, we have these two. So either sometimes there's two answer for it lah. It's either bent or V shape. So once you have known the name, don't forget the structure has oxygen as the terminal, and then draw again all the lone pair. For this case, remember that our selenium oxide here, one of the oxygen on the right hand side is a double bond. For chapter 4 chemical bonding, all the electron pair geometry or molecular geometry is something that you have to memorize. Okay, so there's a simulation website where I have included in the description as well. So you can actually refer to this one lah. Okay, so you're just gonna, when you click to the website, okay, choose the model. Okay, just now we have seen that selenium oxide has two bonding pair, the same as what is shown here, and then we know that we have one lone pair. Okay, and then we can see that, and then you can go to the most left hand side, bottom left hand side. You can see there's the electron geometry, trigonal planar, molecule geometry is your band. Again, this simulation you can use for your revision. So for example, I'm going to remove my lone pair. So if I remove my lone pair, you can see that they actually, for the electron geometry, the name is linear, molecular geometry is linear. This is what I've said. For structure with no lone pair, the electron geometry or the EPG will be the same as molecular geometry. So you can add up until the maximum we have learned until 6 lah. Okay, or you can remove and you add your lone pair. Okay, so you can see for this case we have 5 bonding pair. We have one lone pair. So the electron geometry is octahedral. The molecular geometry is square pyramidal. Question 3 Roman, determine hybridization of the central atom. So hybridization, what we have learned is sp, sp2, sp3. Okay, and then we don't have any sp4. Why? Because p, the maximum number is only 3 lah. So we got sp3d, sp3d2. So how do we determine the hybridization? It is based on this. If we have total electron pair to be 2, then it will be sp lah. Why? Because we have 1 s, 1 p. So total 2. If we have total 3, we have sp2. Why? Because we have 1 s plus 2 p. So this total 3. If 4, sp3, 1 s plus 3 p. So here total is 4. Okay, so to determine the hybridization, first you must have the correct Lewis structure. Okay, why? Because then you know the correct class, electron pair geometry, molecular geometry. For the hybridization, mostly based on your class lah. Okay, so again, this the total ni must, it's not only the bonding pair, it must be bonding pair plus lone pair. Okay, the total, this one, then you will get your hybridization lah. So for selenium, we have known here the total is to be 2 plus 1. Total is 3. So 3 is sp2. Okay, so the question asks what is the hybridization of central atom. So we know that selenium is sp2 hybridized. Okay, so again, why do we have 3? Because 1 lone pair plus 2 bonding pair. For example, if I have CH4, my CH4, we have 4 bonding pair, right? 1, 2, 3, 4. So 4 sp3. Okay, water H2O. So we have 2 bonding pair and then 2 lone pair, total 4 sp3. This case, even though we have double bond, again count how many bonding pair, how many lone pair. Okay, so that's for question 3. Last but not least, question 4. Question 4 Roman, explain whether Se2 is a polar or non-polar. Okay, so to determine the polarity, we must refer back to the shape lah, the molecular geometry, not the Lewis structure. Must refer back to the molecular geometry. So I'm gonna draw it again. So this is the molecular geometry. Okay, next, when it asks for explain whether polar or non-polar, we have 3 points. Okay, so the first point we have to mention, is it the Se oxygen, is it polar bond or non-polar bond? Okay, for the case of selenium oxide, we have Se single bond O and Se double bond O. So I'm just going to write down. Okay, the selenium oxygen and selenium oxygen double bond is actually are polar bonds. Okay, why do we define it or we mention it as polar bond? Because polar bond consists of two different atoms. Okay, while non-polar bond consists of the similar atom. So what does it mean? Okay, if this bond has two different atoms, so that is what we call polar bond lah. For example, if I have my oxygen. Okay, so this bond consists of two similar atoms. So this is non-polar bond lah. The same goes for nitrogen. Okay, this is non-polar bond. But this case, selenium and oxygen is two different bond. The same goes here, selenium oxygen. We compare it in terms of this. Because the bond is SeO and SeO. We don't have any oxygen bond. We don't have lah. Okay, so next. Okay, so that is the first point. The second point is we have to draw the dipole moment. Okay, because polarity is based on the resultant dipole moment lah, whether it cancel out or does not cancel out. Okay, so to know whether it cancel out or not, we have to draw the dipole moment towards more electronegative atom. For the electronegativity, so for period 2, remember SNOF, carbon, nitrogen, oxygen, fluorine. So that's increasing electronegativity. Or for any group 17, will be FCl, bromine, iodine, where the electronegativity decrease down the group lah. Okay, so in this case, which one is the arrow for our dipole moment? It will be towards our oxygen. So I'm going to show it towards oxygen for both of the bond, because we have two bonds, right? So we have to show the two dipole moment lah. So what does it mean? So it means that does it cancel out or not? Okay, because if we have this type band, so the resultant dipole moment is downwards lah, does not cancel out. For example, if I have selenium oxide, if this is any atom that is linear, then if a linear bond, this one will be cancelled out lah, this one. But then for the selenium oxide here, we have band shape, so the resultant dipole moment that's downwards. Okay, so what will be the point? We have to write down the dipole moment cannot cancel each other, or mu is not equal to 0 lah. It's either these two, either this one or this one. Okay, so it means that it does not cancel out. So what does it mean if does not cancel out? So it means that our SeO2 is a polar molecule. If the question asks to explain or determine, then you have to show these 3 points lah. First, you have to mention is it polar bond ataupun non-polar. This case because we have selenium single bond oxygen, selenium double bond oxygen. So I've mentioned about those two are polar bonds. Okay, and then show the dipole moment for each of the bond, and then we simplify it, either cancel or cannot cancel each other. So if mu is not equal to 0, hence it will be polar. If it's equal to 0, it will be non-polar. Okay. Question B. Calcium is a silvery white soft metal that tarnish easily in the air. By using the electron C model, illustrate the formation of metallic bond. Okay, and explain the electrical conductivity exhibited by calcium. Okay, so this question I have discussed in a video, okay, where this is the answer or the explanation. So this is actually in a video, so I'm just gonna link the video in the description, so you can refer back lah to the video itself on how to answer this question. So this is for explanation. They did ask about the formation of metallic bond in terms of electron C model, so you have to draw. Again, please refer to the link in the description, where I'm going to go straight to the timestamp where I've discussed the question itself. Question C. Aluminium conducts electricity, but aluminium chloride does not. Explain. So this question actually refer back to the question B lah. It's about aluminium is our metal, so about our metallic bond. Okay, so we have to explain it in terms of words because there's 5 marks. Okay, so what I'm going to explain first is in terms of aluminium. Okay, so there are 3 points there. So first point, you mentioned that aluminium is a metal. So for each of the aluminium aluminium atom, it can donate 3 electrons. So here I'm just going to show you the electron C model for you to show, because when we're talking about metallic bond or metal, we've mentioned about the electrostatic attraction between the cation and the electron and the C of electron, right? Okay, so where do we get the C of electron? It's basically based on the atom itself. So here for each of our aluminium, it donate 3. It donated 3 electron. Okay, so for example here I've drawn 6 aluminium atom. So for each of the aluminium donate 3 atoms, so it means that we have 18 electron lah. Tapi sebenarnya in a compound we have multiple small atom, multiple atoms. Okay, so here as we can see, there's the electron, C of electron. This is what we call delocalized. Delocalized, or it means that free moving. The electron is mobile lah. Okay, so once the electron is mobile, so it means that it can conduct electricity itself. Okay, so that's why our metal can conduct electricity and heat. Okay, so that is for aluminium. So what about aluminium chloride? Aluminium chloride is a covalent compound. Okay, so if it's a covalent compound, so in this case again, because aluminium has the free moving electron, so that's why it has several characteristics. But this case for the covalent compound, so it means that it does not have any of that lah. So I just mentioned, it has no delocalized or free moving electron to conduct electricity. Okay, so this part is actually explanation a bit lah. Okay, so that is the solution for the question 3 for PSPM 2022-2023.